What if you could experience the final seconds of your life, one stretched out heartbeat at a time, as you fell into the most mysterious object in the universe? Imagine time itself slowing, light bending into impossible shapes, and your body stretching like a thread across eternity. This isn't science fiction. This is physics. In the next few moments, we're going to explore, second by second, what it would actually feel like to fall into a black hole. Not just what would happen to your body, but to your perception, your mind, your sense of self. Welcome to the edge of reality. Introduction to black holes. Black holes are formed when massive stars exhaust their fuel and undergo gravitational collapse, compressing their entire mass into an unimaginably small volume. The result is a singularity, a point of infinite density surrounded by the event horizon, the ultimate point of no return. Once something crosses that boundary, it is forever lost to the universe outside. But while that may sound ominous, it's also captivating, because beyond science lies something profoundly human: the desire to know what it would feel like. There's more to this movie than just black holes. It's about what you would feel, what your senses would pick up, how your thinking might change, and what the last few seconds of your fall into the universe's strongest gravity field would be like. This isn't your average school break or sci-fi side trip. Step by step, it takes you into the heart of a black hole, taking you on a trip through physics, perception, and in the end, self-erasure. To begin to understand this journey, we must first understand black holes, not just as astrophysical objects, but as conceptual entities that challenge everything we thought we knew about reality. At the core of a black hole lies the singularity, a point where space-time curves infinitely and our mathematical models break down. Around it lies the event horizon, the invisible boundary that marks the limit of escape. And surrounding that often is the accretion disk, a seething, glowing halo of gas and dust spiraling inward at near light speed, heated by friction and radiation until it blazes with X-rays. Even though black holes are very powerful, they can't be seen directly. They don't give off light, so we can't see them. We know they are there because of how they affect the things around them, like how stars move through space at incredible speeds, or how matter disappears into an unseen maw. Even the best pictures we have, like the one taken by the famous Event Horizon Telescope of the giant black hole in the galaxy M87, only show the shadow, which is just a shape against the bright light of the falling matter. Despite how strange black holes look, they are controlled by the same basic forces that affect our everyday lives: gravity, electromagnetism, thermodynamics, and quantum physics. The change is the size. These forces are sped up to an astronomically huge level by a black hole, which shows behaviors that can't be seen anywhere else. They are places where the impossible is tested, and where the very fabric of the world is bent beyond recognition. So what would it feel like to fall in? To answer that, we need to turn to one of the most profound concepts in modern physics: general relativity. Proposed by Einstein in 1915, this theory revolutionized our understanding of gravity, not as a force acting at a distance, but as the curvature of space-time itself. Objects with mass bend the fabric of the universe, and other objects move along the curves in that fabric. The more massive the object, the deeper the curve. Black holes are the largest holes in the fabric of space-time. Their gravitational fields are so strong that they change the shape of time and space. It's no longer normal to follow the rules once you fall in. It stops making sense to go up and down. In strange ways, distances stretch and squeeze. Time, our steady friend, starts to act like a trickster, slowing down and warping in ways that don't make sense. Imagine standing on a spaceship near a black hole. Not too close, but within sight. You look out the window and see the stars around the black hole distorted into rings. The light is curved by gravity, wrapping around the black hole's event horizon. You're watching something that seems like a portal, not into another place, but into nothingness. It's mesmerizing, terrifying, beautiful. As you begin your descent, your clock ticks normally, but everything outside your window changes. The light dims. The stars shift, space seems to fold in on itself, and with each passing second you are pulled deeper into the well, where time and space begin to lose their meaning. This is where our trip really starts. the black hole isn't just something you fall into. It's a line where experience starts to fall apart, where your memories, feelings, and even your awareness start to change shape, and maybe even fall apart. This trip won't be counted in meters or kilometers, but in seconds. Each second will be a world of changes in how you feel and what you think. Because when we ask, what would it feel like to fall into a black hole? We're not just asking about physics. We're asking what happens to you. What would your eyes see? What would your brain feel? Would time slow to a halt? Would you see the universe's end or its beginning? This is how you'll get into the black hole. This is your trip to the very edge of everything, 1 second at a time. The concept of time dilation. As your descent begins, you notice something peculiar. It's not the pull of gravity. You're in free fall after all. It's not the heat or the pressure or any loud alarm sounding. It's time itself, or rather, how everyone else's time seems to be accelerating around you, while your own moves steadily on. Welcome to the mind-bending reality of gravitational time dilation. Einstein's theory of general relativity says that time will stretch out. From the point of view of someone in a gravity field, time moves more slowly when the field is greater. On Earth, this effect is so small that we don't even notice it. Since GPS satellites are farther from Earth's gravity, their clocks tick a little faster than watches on the ground. But close to a black hole, it is no longer possible to ignore the difference. Imagine you're communicating with a friend stationed safely on a distant observation ship. As you inch closer to the event horizon, you send out video logs, snapshots, or maybe just voice messages. At first, everything seems fine. A few seconds pass for you, a few seconds pass for them, but the closer you get, the more distorted the exchange becomes. Your friend begins to see your updates arrive slower and slower, stretched out in time. A message you record in 10 seconds takes a minute to reach them, then 2, then 10. Eventually, they see your last transmission frozen mid-sentence, your image forever suspended at the edge of the black hole. From their perspective, you never actually cross the event horizon. Your descent appears to asymptotically slow down, hovering just above the threshold for eternity, redshifted to near invisibility. But from your point of view, time feels normal. You fall freely, unaware of how bizarre your movement looks to anyone watching from afar. This isn't science fiction, it's a measurable effect. If you carried a precise atomic clock with you on the way down, it would tick at a different rate than one left back at the ship. The deeper into the black hole's gravity well you go, the more time slows. At the event horizon, time seems to come to a standstill, for everyone but you. Now pause and really think about this. What does it mean to have your personal sense of time become disconnected from the universe's? It means that during your fall, you may witness an accelerated future. Depending on the mass of the black hole and your path inward, it's possible, though still theoretical, that you could look out and see the universe evolve. Stars aging rapidly, galaxies spinning faster, redshifting into oblivion. In the span of your final seconds, eons might pass outside. Civilizations could rise and fall. The universe itself might darken toward heat death. The difference between your mental time and the time outside of you is not just interesting from a scientific point of view, it's also very disturbing. Your breath, heartbeat, and thoughts stay the same, but the universe outside your falling frame speeds up, gets faster, and finally gets too complicated to understand. You don't think time is warped. It is, though, at its core. If you used tools to try to measure this confusion, you would find that everything around you was working normally. Physics is the same where it is. But if you look out to where the universe is going out into space, you'd see that light has been bent, moving toward red, slowing down, and finally going out. When you get close to the black hole's event horizon, things start to stretch, blur, and fade. And there's a twist. You might be able to experience time stretching to its limits if you use strong rockets to stay just outside the event horizon. From your point of view, seconds go by, but from the point of view of the world, millions of years may go by. In theory, this makes it possible to go back in time and visit the future. It does this not by speeding up time, but by letting everything else move faster while you stay almost still. Of course, Hovering at that boundary would require unimaginable amounts of energy. But it underscores a haunting truth. Gravity isn't just a force, it's a sculptor of time itself, and black holes are its most radical tools. Now let's bring it back to you, the traveler. There's nothing strange about how you feel as you fall toward the black hole, but for people behind you, the seconds stretch and twist. You slow down from the outside. Everything keeps going from the inside. This tension, the sense of routine in the midst of cosmic distortion, might be the most confusing part of the experience. It's not clear to you that your fall is being watched very slowly. You are just falling. And this is where the story almost becomes poetic. At some point, you'll cross a line where you can't talk to anyone else. Your friend can't get any more light from you. Your last signs take longer and longer to send until they never get there at all. Your last words are lost in the radio quiet of a world that is changing. Meanwhile, your personal timeline marches on. 10 seconds, 11, 12. Maybe you're aware of what's happening, maybe not. But your consciousness is experiencing a deeply local, subjective version of time, one that no longer matches anything outside. You've become a ghost in the cosmos, temporarily divorced from everyone who ever knew you. And that's just the beginning. As the next steps play out, time dilation will continue to change how you see reality. There will be strange lights, science that doesn't make sense, strong tidal forces, and a slow loss of sensory clarity from now on. Not only are you leaving the world as it is, but you are also leaving your place in it. One last thing before we move on. In some made-up situations, like with giant black holes, it might be possible to stay alive for minutes or even hours before becoming spaghetti. In these situations, time slows down even more. You could fall for minutes while billions of years go by outside. It's possible that you could see stars die, planets dim, and the world go into a long twilight before your own story ends. Approaching the event horizon. The darkness gets worse. It's not just black. It's an absence, a hole so big that it swallows up all light, all detail, and all direction. You are still falling, but you have no weight on you. But now, a basic part of you starts to scream. You are getting closer to the event horizon, which is the edge of reality. This is where the line is. The line past which no light, sound, or data can ever come back. It's not a wall. There isn't any noise or flash. It's quiet. It was very quiet. And completely ending. To you, it might look like a black object floating in space, with a glowing ring of hot gas and dust encircling it. The event horizon, on the other hand, is a mathematical limit, not a real one. That line is almost in front of you. As you draw closer, visual reality begins to melt. First, you notice that stars in the sky behind you begin to curve and stretch. They swirl around the black hole, forming a distorted halo. This is gravitational lensing. Light from the stars is being bent around the black hole's immense gravity. At some angles, you may even see the back of your own head, the light having looped around the black hole and back into your eyes. But this light show is only part of the sensory disorientation. As you descend, the black hole seems to warp from a distant sphere into a flattened, ever-growing disk. It expands to cover more of your field of vision. What you're seeing isn't just the object ahead of you. You're seeing the warped fabric of space-time itself, distorted to the edge of recognition. Time is still ticking normally for you, internally. 1 second, 2 seconds. Your thoughts remain sharp. But around you, light behaves unnaturally. Colors shift toward red in the direction you're looking, and toward blue behind you. It's as if you're falling through a tunnel of time-warped color. And still, there's no sensation of motion. The strange truth is that you don't feel like you're moving, even though you're rushing toward a part of reality from which you can't escape. Not a scratch. Sure, you're going faster, but so is everything else. As you fall, space falls with you, like you're in a waterfall with no way out. If you were part of a research probe, your instruments would be going haywire trying to track motion and direction. Light behaves erratically. Radar loses coherence. Gravity readings spike in unpredictable directions. Orientation becomes meaningless because there is no longer a fixed frame of reference. You're not falling through space, you're falling with it. And then you notice the light fading, not instantly, but gradually, like the dimming of a theater before a performance. Photons from distant stars begin to redshift, lengthening in wavelength until they slide into invisibility. What once was a sky filled with stars becomes a narrowing ring of fading light. It shrinks, tightens, and begins to resemble a dim halo circling the black hole behind you. This is the edge of observable space, your last connection to the outside world. It's not just what you see. Sounds would also fade away in space if they were possible. Your heart beats quietly. Inside your suit or vehicle, your breath can be heard. Outside, there is only the void left. Then comes the psychological compression. As the visible world fades behind the black hole's gravity curtain, a feeling of being alone grows. Not the loneliness of being far away from home or in a spaceship by yourself, but the loneliness of being in space. You can't be seen now. They will never get any signal you send. You've reached a point where talking to the outside world is no longer useful, and yet you haven't crossed the event horizon. Not quite. This is the liminal space, the edge of the edge, the last outpost of knowable existence. Just beyond this lies the ultimate frontier, one no information or light has ever escaped. Your surroundings become increasingly abstract. Shapes dissolve, angles become fluid. Space twists around you like a Mobius strip on a cosmic scale. If you were watching a countdown, it might say something like T minus 0.00001 seconds to event horizon. But in your personal experience, that fraction of a second feels normal. Time hasn't stopped. You still have thoughts, memories, sensations. Yet the visual field has collapsed into an eerie sphere of nothingness ahead and a rapidly vanishing universe behind. A paradox arises in these final instants before the crossing. You might see the light from the rest of the universe speeding up. Galaxies that once drifted slowly now spin rapidly. Stars burn out in fast forward. The very fabric of cosmic time accelerates outward, even as you remain still inside your falling frame. The universe outside plays its final act, and you, helpless, falling, become the lone spectator. Because what comes next is irreversible. There's no physical threshold to cross, no sound, no flash. But this moment, this boundary, is the dividing line between falling toward a black hole and being inside one. It is the moment that physics becomes philosophy. That experience becomes speculation. From now on, no one outside the black hole will ever know what happens to you. Your reality is cut off from the rest of the universe. Everything you're going through right now is unique to you and is locked away in a shell of infinite gravity. Crossing the event horizon. You don't feel it. There's no jolt, no sudden change, no bright flash or cosmic alarm. You simply glide across an invisible boundary in space known as the event horizon, the point of no return. If someone from the outside was watching, they would never see this moment. They see you stopped in time, just above the event horizon, and your fall seems to go on forever. Your picture would slowly fade away, red shifted into darkness, getting darker and longer until it was no longer visible to them. But you, in your frame of reference, time keeps moving forward. Wait a second. For 2 seconds. You can still think and feel things, and you're still falling. This is where your experience and the universe's perception diverge forever. Crossing the event horizon isn't like stepping through a door. It's more like passing a mathematical limit. The laws of physics, as we understand them, don't break down here, but they begin to transform. The roles of space and time invert in the black hole's interior. Outside, time moves forward, and you can move freely in space. Inside, space becomes time-like. You can no longer choose your direction. Instead, you are being pulled forward by gravity, as if it were the passage of time itself. And just like time, you can't resist it. You are no longer just falling toward the center of the black hole. In a very real sense, you are moving into the future at a rate dictated by gravity itself. And that future has only one destination, the singularity. Inside the event horizon, all paths lead inward. There's no going back. Any attempt to stop, escape, or even alter your trajectory is meaningless. Just as you can't choose to go backward in time, you can't stop falling toward the singularity. The universe outside begins to dissolve. Space curves back on itself, and your view of the outside world becomes increasingly surreal. The stars that once surrounded you are now warped into a bright, distorted ring around your field of vision, concentrated behind you in a strange luminous halo. It's as if the entire cosmos has been pulled into a shrinking spotlight you can no longer reach. In front of you, absolute darkness. No stars, no glow, not even the faintest flicker of light, only the blackness of the singularity ahead. You are now trapped within a gravitational funnel so deep and steep that even photons cannot climb out. If you look around, you'll see strange visual effects like duplicate pictures, streaks that go on forever, and flashes of twisted geometry. The rules of sight no longer hold true. Light bends so much that it can go around the black hole more than once before it gets to your eyes. You might even see more than one picture of yourself, stacked together like a live echo, taken at different times and from different angles. And while your vision is now contorted and collapsing, your body is still experiencing free fall. There is no floor, no drag, no pressure. Gravity is pulling on every atom of your body equally. So despite being deep inside the most violent gravitational field in the universe, you still feel weightless. As you continue your descent, the gradient of gravity, called a tidal force, grows stronger. Your head and feet may begin to feel different gravitational pulls. This difference will intensify. Soon, the gap will stretch atoms themselves. But not yet. In this brief moment inside the event horizon, you're still relatively intact, still aware, still thinking. Everything you've ever known, every planet, every galaxy, every equation lies behind you. And ahead, the rules dissolve. Physics begins to fray. Our theories lose their power. We can model black holes up to this point. Beyond that, only speculation. Einstein's general relativity tells us the math here curves toward infinity. Densities become unimaginable. Time compresses, space collapses. But quantum mechanics, the theory of the very small, disagrees. The two pillars of modern physics cannot coexist in this regime. And so, you float within the chasm between two realities, a traveler in a place where science falls silent. You might begin to wonder, will I die now, or have I already died? But this moment is stranger than death. You are still experiencing, still feeling time move. You may have mere seconds left. Seconds that, due to the warped space-time, might feel extended, dreamlike, or paradoxically infinite. Some scientists think that your mind, caught in this strange time dilation, might feel like it's been forever in the last few hundredths of a second. Some people say it's over very quickly. In any case, you're now in a tube that only leads to one place. At the other end, there is something so dense and squished that nothing in the world can stop you. Could the singularity be a gateway, a bridge to another universe, a wormhole to another region of space-time? We don't know. It's possible. Mathematically, certain solutions to Einstein's equations allow for it. These ideas remain purely theoretical, but in this moment, inside the event horizon, speculation becomes your last frontier. Do you really end your fall if no information can get out of the black hole, or is it built into the framework of space-time so that it will never change? Does the black hole remember you? Physicists like Stephen Hawking thought about this a lot, which led to arguments about whether knowledge is really lost. It's possible that your trip and the seconds you spent falling are written on the surface of the event horizon in a cosmic record that we can't read yet. And still, time moves. Not for the universe, not for the outside, but for you. 1 second, 2 seconds, 3. The universe behind you fades into myth. The singularity ahead looms ever closer. In the space of a breath, you have crossed a boundary that cannot be uncrossed. And though the world can no longer see you, you remain, falling, experiencing, changing. Gravitational redshift and blue shift. Light, the fastest thing in the universe, becomes a prisoner of gravity. As you fall deeper into the black hole, your experience of light, the very essence of vision, begins to change in ways that are as beautiful as they are terrifying. It starts subtly at first. Stars behind you shimmer oddly. Their colors shift. Patterns you know, constellations, galaxies, the familiar flicker of starlight begin to warp. This is the phenomenon of gravitational redshift and blue shift. And it means the black hole is not just devouring matter, it's twisting light itself. In everyday life, you've seen something similar with sound. A siren rising and falling in pitch as an ambulance passes by is due to the Doppler effect, the compression and stretching of sound waves caused by motion. Light behaves the same way. But in this case, it's not just motion doing the stretching, it's the very fabric of space-time. As you fall in, light coming from the universe behind you, up and away from the black hole, is stretched out. Its wavelengths elongate. Blue becomes red. Red becomes infrared. Eventually, it fades from visible light altogether. The universe dims. This is not just a filter effect either. It's not just a color on your eyes. Physics is changing the way all of your senses work. It is so hard for photons to get to you that you are falling into a very deep gravity well. The stronger the gravity, the more energy those photons lose as they try to get away from it. When they get to your eyes, they are longer, not as strong, and colder. The stars appear redder and dimmer, not because they've changed, but because your position in the universe has. And if you look down, toward the singularity, the opposite happens. Light that was already headed inward is falling alongside you, but you're accelerating, gaining speed as you fall. From your perspective, this inward falling light is being compressed, its wavelength shortened, its colors shifted upward into the blue and ultraviolet. This is blue shift, a tightening of light's wavelengths due to your acceleration toward its source. It's like the universe is gathering intensity ahead of you, pulling colors toward the highest frequencies imaginable. Red shift behind, blue shift ahead. In those fleeting seconds, it's as if you're riding a beam of light through a surreal tunnel, one end glowing brighter and hotter, the other fading into shadow. The cosmos is no longer symmetrical. The black hole has made the universe directional, painting your fall in gradients of energy. Some scientists think that the blue shift can get so strong as you get closer to the singularity that even faint background radiation, which is made up of photons from the Big Bang, can be turned into blinding bursts of energy. You might see light flashes ahead, like the past is being played over and over again to make a firework of origin energy. If your eyes were still working, you would see a cosmic finale. But this comes at a cost. The extreme blue shift means not just brightness, but heat. Photons gain energy as they fall with you, and what was once harmless background radiation could become high-energy gamma rays, enough to cook the atoms in your body. You wouldn't just see light, you'd be burned by it. Your visual cortex, your optic nerves, your retinas, overwhelmed by a universe condensed into a laser beam. And yet, the brain might still register something before being obliterated. Perhaps a final flash. A tightening tunnel of blue-white light ringed by shadows where galaxies used to live. An inversion of color so intense it defies language. A hyperspectral climax at the edge of physics. But remember, what you see isn't the universe as it is. It's the universe as warped by gravity, time, and your trajectory. These distortions aren't just optical, they are experiential. This is your new reality, one where direction, time, and energy no longer behave in ways we understand. You are in a place where light doesn't follow any rules. Now think about this. If someone else were to fall in line with you, either slightly ahead or behind, their view of the world would be very different from yours. The red shifts, blue shifts, and directions of their light were all changed, sometimes in small ways, and sometimes in big ways. That's the cool thing about relativity inside a black hole. Position, speed, and gravity shape each experience in its own way. If you could communicate, if you could compare notes in real time, you'd find that even reality itself is non-universal. And here's something else. Time affects the way you perceive color too. As seconds stretch under the immense pull of gravity, each moment might feel longer. In that slow drip of time, the fading red light behind you doesn't vanish instantly. It bleeds away, stretched and smeared across time. You watch galaxies fade into a deeper crimson, then into a dull ember. It's a cosmic sunset that never quite ends, until even infrared light is too weak to detect. Eventually, your rearward vision becomes black. Not darkness, but absence. No photons, no signal, a cosmic blank slate. And ahead, the blue shifted glare collapses into a central eye of brilliance. perhaps the last thing you'll ever see. In these final visual seconds, because yes, even light has a timer here, you are witnessing not just the extremes of physics, but the limits of perception. Light, which once told you where you were, where you'd been, and where you were going, is now reduced to a directional scream of energy. Vision as you knew it dissolves. What remains is sensation without sight. Perhaps you begin to perceive other wavelengths, ultraviolet flashes in your skin, X-rays humming in your nerves. Perhaps the sensory overload collapses into synesthesia. Colors as sounds, brightness as pressure, blue shift as a kind of cognitive fire. The light has run out, the colors have died. Your frame of reference has unraveled. In those final seconds of descent, vision may become memory, your mind echoing with the ghosts of photons that no longer arrive. Red shifted past behind you, blue shifted future ahead, and between them, a human observer, falling forever, illuminated by physics that no longer cares whether you see, feel, or understand. Spaghettification, tidal forces at work. The name sounds absurd at first. Spaghettification, as if falling into a black hole turns you into pasta, but don't let the humor fool you. This is perhaps the most violent, extreme, and final process your body will ever undergo. Let's rewind to high school physics for a moment. Gravity pulls on objects, but if gravity is pulling harder on one end of something than the other, you get a tidal force. On Earth, that's what causes the ocean tides. The moon pulls more strongly on the side of the Earth closer to it than on the far side. It's a gentle stretch. In a black hole, it's not gentle, it's apocalyptic. As you fall feet first into a black hole, the gravitational pull on your toes is stronger than the pull on your head. And it's not just a little stronger, it's exponentially more powerful with every centimeter closer to the singularity. The closer you get, the faster this difference escalates. Your body begins to stretch and stretch. Imagine every atom in your feet being pulled faster than the atoms in your calves, then your thighs, then your chest, then your skull. This isn't like being torn in half. It's like being drawn into a thread, a line of matter extending longer and thinner with every nanosecond. This is spaghettification, the process by which your body keeps getting longer and longer until it's just a long, very thin strand of matter. It's not just your body being pulled apart. Your bits are it, your atoms. Under the pressing force of gravity, even the spaces inside of atoms might start to change shape. The scary truth is that you wouldn't even know it was happening, not right away. You still don't feel any weight when you're in free fall. You can't push up from a platform below you, no straps pulling down, you're just going down, and that gives the impression of peace. At first, it's imperceptible. You might still feel intact. You might even feel calm, like a diver drifting downward in the deep sea. But by the time your feet have reached a region of gravity, tens of thousands of times stronger than your head, the calm would break. Blood vessels rupture, skin begins to shear, nerves misfire. Pain signals flood your brain until your spine itself begins to unravel. And then something strange happens. You become a line, not figuratively, literally. Your physical structure elongates into a strand, perhaps thinner than a human hair, yet kilometers long. You don't break apart into pieces. Gravity won't let you. It holds you together, stretches you instead of shredding you, as if the black hole wants to eat you as one continuous meal. This isn't death in any traditional sense. There's no moment where your heart simply stops and your eyes close. This is the erasure of form, a geometric dismantling, an ontological insult. You don't just die. You are geometrically unmade. And yet, here's the most mind-bending part. Depending on the mass of the black hole, this could happen either before or after you cross the event horizon. In small black holes, say the mass of a star compressed into a few kilometers, tidal forces become fatal well before you hit the event horizon. You'd be shredded into strands of subatomic matter while still outside the black hole's boundary. Supermassive black holes, like the ones at the center of galaxies, the event horizon is so large that the tidal gradient is gentle at first. In these giants, you might pass the event horizon completely intact, no stretching, no pain. For several seconds or even minutes, you'd fall freely, feeling nothing out of the ordinary. And then, only near the singularity itself, the difference in gravity between your head and your feet becomes catastrophic. Spaghettification doesn't greet you at the doorstep. It waits quietly until you're deep within the heart of the black hole, and then it strikes all at once. This is where the abstraction becomes emotional, because if you're still conscious at this point, and we have no way of knowing whether the brain would still function in such a stretched form, you might experience the longest final second of your life, not because time stretches, though it does, but because your physical existence is being unraveled over that second. At that moment, your memories may be distorted. Your thoughts, if they continue, could become fragmented. You could see your life, literally, strung out before you, neuron by neuron, as your body is pulled into a line. There are no witnesses, no escape, no undoing. You become a part of the singularity's path, your fall becoming real and written in space like a mark in light years of pain. And when it's all over, there might be no sign of you in our world. The data, your body, your past, and your DNA are all stored somewhere in the black hole. They may be smeared on its event horizon as holographic data, or they may be destroyed by the singularity and never be found again. The sensation of weightlessness. It may sound contradictory. You're being pulled into a cosmic abyss with unimaginable gravitational force, yet you feel nothing, no pressure, no tension, no weight. Welcome to the illusion of weightlessness. When you fall into a black hole, the environment may look wild and dramatic from the outside, but at first it feels very calm and peaceful inside. You feel like you're flying, not stable, in a calm fall that feels a lot like being underwater without any pushback. To understand why this is, we need to go back to one of the most beautiful insights of Albert Einstein, the equivalence principle. In simple terms, Einstein's theory of general relativity tells us that freefall is indistinguishable from floating. In a spaceship orbiting Earth or an elevator plummeting through space, you experience no sensation of gravity because you're not resisting it, you're surrendering to it, you're falling. We feel weight because the ground is pushing up on us every day. The floor is under our feet. Our chairs make our backs hurt. These are regular forces, like gravity. But if you take away those supports, you won't feel any weight. That's why people in space don't feel any weight. There is no relative force because both of them are falling toward Earth all the time. Now take that same idea and drop it into the most extreme gravitational field in the known universe. The result? A surreal paradox. The stronger the gravity becomes, the less you feel it, so long as you're falling freely. Now, picture yourself falling headfirst toward the event horizon in a small sealed box. The sky outside your window bends and twists. The stars seem to go around the black hole at speeds that aren't possible. Light itself twists and turns. But on the inside, keep quiet, being still, holding back. The box doesn't move. You don't move. Your body doesn't touch anything. You might even think you're not moving if you close your eyes. You are going faster than you ever have before, even though it seems quiet. As you get closer to the event horizon, the black hole's gravity speeds you up even more, up to a large part of the speed of light. Anywhere on your body feels the same speed though, so there's no pulling, pressing. When you look at relativity, speed feels like force. In freefall, on the other hand, there is only motion and no relative force. You just fall. Even though this experience is real in a physical sense, it is also upsetting to me mentally. You know you're going to fall. You can see it. You can feel that the light around you is becoming more and more distorted. But your body doesn't tell you anything. You don't feel anything like a roller coaster drop in your stomach or a pull on your chest. It's strangely quiet when bad things are about to happen. Let's talk about your inner ear, the part of your body responsible for balance and spatial orientation. On Earth, it works by detecting changes in acceleration and direction. In a black hole freefall, however, the input flatlines. Your inner ear detects nothing unusual. There's no tilt, no spin, just equilibrium. That lack of feedback, especially combined with the collapsing visual cues, could lead to a sensation of disembodiment. As the visual universe begins to warp and distort outside the window, shrinking behind you into a dim red-shifted sphere, you feel less connected to your surroundings. The world no longer orients you. Your body begins to lose its sense of where up and down are. Because in this space, direction itself is bending. Near a black hole, the geometry of space-time is so warped that conventional directions become meaningless. You're falling not down in the traditional sense, but along a geodesic, a path through curved space-time. From your perspective, you're moving forward normally. From an external viewpoint, you're being pulled into a funnel of warping dimensions. For some, this could evoke a profound meditative stillness. The absence of force, the quiet, the suspension. It mirrors descriptions given by astronauts during weightless spacewalks. But for others, it could produce an acute existential dread. Because when your body feels no gravity, but your eyes see a collapsing universe, cognitive dissonance takes hold. As a result, a split in your mind between what you know and what you feel. Now picture getting out of the box. You are now floating alone, with no supports, no floor, and no wall. It's just you and the void. As gravitational lensing kicks in, light from galaxies far away swirls around you. Above, below, and inside, stars move around. The black hole below, ahead or around, is a hole in the real world, a dark spot from which nothing can get out. Still, you feel nothing. Not because there's nothing to feel, but because everything around you is falling with you. This is the perfect freefall. Gravity is no longer something that pulls you. It is the environment you exist within. You are gravity's companion now, its instrument. And in this perfect fall, gravity does not push or pull. You simply exist in its grasp. But this lack of weight can only go so far. As we talked about in the last part, you start to feel something, a change. You won't feel force on your skin. Instead, the black hole's gravity will start pulling on different parts of your body in different ways. In this case, not having any weight is its own sign of horror, because its perfection makes it possible for itself to fall apart. The sense of weightlessness breaks down as the gradient rises, reaching a point where your feet are much lower in gravity than your head. There is the first twitch of spaghettification. You don't fall together anymore. You start to stretch. The piece collapses. The silence gives way to internal chaos. And yet, for those brief seconds, seconds that could feel eternal thanks to time dilation, you floated, untouched by force, untouched by pain, suspended in the calm of inevitable collapse. You can really feel how strange black holes are when they are quiet and peaceful, not when they scream or hit something, but when you don't hear or feel anything that we normally hear when we fall. There is no wind, silence, not a pushback, only weight. You are alone, just the fall. Visual distortions in space-time. As your descent continues, the universe around you begins to collapse, not in the literal sense, but visually. The sky that once sparkled with stars begins to bend, twist, and behave like a funhouse mirror gone berserk. The further you fall toward the black hole, the more your eyes become unreliable narrators. This isn't making up stories. This shows the curve of space-time. It starts off slowly. As if you were looking through a fisheye lens, you might see stars that are smeared into arcs along the edges of your field of vision. But these errors get worse in a matter of seconds. Behind the black hole, the light from galaxies, stars, and cosmic dust doesn't go away. It wraps around it. The strongest case of gravitational lensing can be seen here. It bends the background, folds it over on itself, and sends light along the curve of space-time like water going down a drain. The result? You see stars and galaxies in multiple places at once. It's like seeing the Milky Way both straight ahead and behind you, with its light bent all the way around the black hole. The universe goes around and makes copies of itself. As the eye in the middle of a multicolored tube, you see how reality folds in on itself. It is, in every sense of the word, surreal. These distortions are not merely strange, they are predictable, mapped by Einstein's equations. As gravity increases, the paths of photons, the particles of light, curve more sharply. They no longer travel in straight lines. Instead, they spiral, orbit, or plunge inward. For an observer like you, This means that everything you see becomes compressed toward the center of your field of vision. Above, below, to the side, it all rushes inward, converging into a glowing, flickering ring encircling the black hole's shadow. This phenomenon is known as the photon sphere, a region where light can orbit the black hole indefinitely. Some of what you see is not light that just passed by. It's light that's been circling the black hole, possibly for years, before finally escaping outward and entering your eyes. It's not just space that you see. You can tell the time. It's like going back in time when you look at the black hole's photon sphere. It's possible that what you're seeing is the light from long-dead stars that has been warped and bent into forms that are always changing and shimmering around the empty space like a broken halo. In addition, you can see the back of your own head if you look very closely. This is because space is warped. You can send light from your body around the black hole and have it come back to you. This isn't made-up science fiction. It's the way physics works. As your fall goes on, these images get more squished together and powerful. The universe that we can see gets smaller and smaller until it forms a bright, wavy ring. Time dilation adds another layer. Light from the outside world seems to slow down, flash, and then stop. But your own time keeps going. Because of this, it looks like the world is speeding up. Things that happen in the outside world, like stars moving and galaxies growing, seem to be happening faster and faster. In the end, you might see the far future of the universe in just a few seconds, while time speeds by like a fast film loop spinning out of control. All of this happens while the black hole itself remains cloaked in darkness, a shadow in space, perfect and black, absorbing all light that crosses its threshold. It is the ultimate absence, no reflection, no outline. Only the surrounding ring of bent light betrays its presence. Let's look more closely at the Einstein ring, which is a very strange picture. In this case, a background light source, like a star far away, lines up perfectly with your line of sight and the black hole. The galaxy's light is spread out in a perfect circle around the black hole's edge, so it can't be seen as a point or a blob. Of course, it's just an image of place, but it also shows how strong gravity is. As other sources line up in your constantly shifting frame of reference, these rings may stack on top of each other, grow, and break up. Distortions aren't just a cosmic movie, though. They're also personal. Your ability to see starts to fail as you get closer to the event horizon. The strong gravity is stretching the light around you, which is also called redshifting. It starts to lose its color. The blues get quieter and then go away. As the day goes on, greens turn brown. In the end, only deep reds are left because all the colors of light that you can see are too far away for your eyes to see. This process is not always the same. It is called gravity redshift. As your fall speed gets closer to relativistic levels, the light behind you may not look the same as the light in front of you. It's no longer just about bending. Light is being shredded. The black hole's rotation, if it's spinning, adds another wrinkle. In a rotating or Kerr black hole, space-time itself is dragged along in the direction of the spin. This effect, called frame dragging, means that light doesn't simply bend, it's twisted. You're not falling straight in, you're being pulled into a spiral. Light from the universe ahead appears to swirl like a vortex. The visual field becomes dynamic, asymmetrical, flickering with impossible complexity. Now consider this. Your brain evolved to make sense of a stable, three-dimensional Euclidean world. But here, space is no longer Euclidean. Distances are deceptive, angles lie, straight lines are warped. The geometry itself betrays your expectations, and your brain scrambles to reconcile what it sees with what it knows. The result? Cognitive overload. You may experience hallucinations, vertigo, or sensory disintegration. You might feel as though you're falling inward and outward at the same time. You may lose all sense of orientation, unsure whether you're moving at all, or whether the universe is folding around you. Some theoretical physicists suggest that, in the final moments before crossing the event horizon, the distortion becomes so extreme that all directions lead inward. The universe becomes a funnel, every path sloping down toward a single inevitable destination. No matter where you look, you're looking into the black hole. Even behind you is just more curvature. Space no longer extends outward, it collapses. And the visual experience of that collapse is unlike anything imaginable. In those final seconds, time dilation means the universe outside may age trillions of years. You might witness the end of star formation, the dimming of galaxies, the death of suns. You may see the universe grow cold, silent, and dark, collapsing into entropy. All while, for you, only seconds pass. Then, nothing. The world goes away. The light ring gets thinner until it's just a faint image. There is no color left. The darkness gets completely dark. The event horizon is now in front of you, not because it's dark, but because space and time stop acting in a way that makes sense. You can't see what's inside. Your mind, your eyes, and the way you see things were all made for a universe full of stars, shapes, and spaces. But what about this? There aren't any stars. You don't have any directions. There is only the endless curve of space-time and the fall that will never end. The role of accretion disks. As you get closer to the black hole, a new presence appears. It is bright, scary, and beautiful. Even though it doesn't pull you in, it's like a glowing ring of death around the black hole. This is the accretion disk, and this is the last light you'll ever see. An accretion ring is likely to be around the black hole if it hasn't been fully still and has been eating things like gas, dust, or even stars. This is not a still ring, but a storm of material that is whirling and spinning at a very slow speed compared to light. It is unbearably hot and shines brightly across the electromagnetic spectrum. It looks like a ring of fire from far away. As you fall straight toward it, it turns into a source of intense radiation, motion that you can't predict, and too much sensory input to handle. You don't fall into the disk. Rather, the disk orbits the black hole in a plane, and unless you've entered from a specific angle, you may fall perpendicular to it, but it is impossible to ignore. The light alone is staggering. The gas in the disk is heated by friction and compression to millions of degrees, emitting light in X-ray, ultraviolet, and visible wavelengths. What you're witnessing is one of the brightest, most energetic objects in the universe. In fact, from a great distance, accreting black holes outshine entire galaxies. Now picture falling right into one. It doesn't just hit you as a glow, it hits you as a wall of force. Depending on how big the black hole is, the radiation could kill all living things right away. X-rays, gamma rays, and other photons with a lot of energy tear through the space around the black hole like shrapnel that you can't see. At first, you wouldn't feel any pain. Almost right away, your feelings would be fried, shut down, or killed. It would be very hot, full of radiation, and very chaotic. This disk isn't flat. It warps upward and downward, pushed and pulled by the black hole's gravity and spin. Instabilities in its flow cause shocks and flares, bursts of plasma erupting like solar storms on a scale too big to imagine. Some of these jets can extend thousands of light years into space, fired from the poles of the black hole. And even though you might not fall directly into them, their energies interact with the surrounding space, saturating the environment with high-speed particles and magnetic chaos. From your perspective, the disk isn't even round anymore. Due to relativistic effects like Doppler beaming and aberration, the side of the disk moving toward you appears much brighter than the side moving away. The colors shift, the symmetry breaks. One side glows with violent blues and whites, the other recedes into dull reds and shadows. The disk seems to be spinning faster than possible, and yet it's all entirely real, just distorted by the rules of relativity. You may see flashes of light, bright arcs and bursts, where clumps of matter collide in the disk or spiral inward and vanish into the event horizon. Each flash is a funeral pyre, a last scream of photons as material gives up its final energy to the abyss. There's a pattern to these screams as well. They happen in waves that are almost cyclical, a pattern of flashing that shows how the inner disk moves. To learn more about black holes, scientists look at these trends. But from your point of view, they're not readings. They're flickers in your vision, pulses of light in a night that's getting darker. Some of the matter in the accretion disk never makes it in. It builds pressure. It escapes in polar jets, streams of plasma accelerated by magnetic fields and the black hole's rotation. These jets pierce through galaxies, altering star formation and structure on cosmic scales. You might not fall into one, but their shockwaves permeate the space around the black hole, rattling your senses and possibly irradiating your body with intense, incoherent bursts. The heat, the noise, the overwhelming brightness, all this plays against the backdrop of darkness itself. The accretion disk glows only because it hasn't yet fallen in. Once matter crosses the event horizon, all emission stops. Light ends, sound ends, even energy transmission ceases. The contrast is stunning, everything glowing just outside the black hole, and then the void. The stranger part, you might not be burned right away. When you're in free fall, you don't have to fight gravity, you're going with it. In a strange way, this means that you might not feel anything nearby, even though the world around you is howling with energy. There is no normal way for you to feel heat, but the radiation goes through you, and maybe breaking down your molecules. You don't burn in fire. You disappear in forces that can't be seen. Let's think about what this would sound like if we could hear it. It goes without saying that sound doesn't move through space. What if you could hear the accretion disk through particles moving in your body or suit? It would not be quiet. Deep seismic hums could be made from its electromagnetic waves. These are the tones of death, with rhythms that echo with unimaginable force. The black hole's surroundings would vibrate with cosmic noise. Not just the disk, but the magnetic fields, the plasma winds, the quantum disturbances at the edge of space-time. It would be like falling through the static of an ancient television tuned to a dead channel, but amplified 1 billion times. As you draw closer to the event horizon, the brightness of the disk increases one last time. But then, suddenly, it fades. Why? Because now you're falling past the point where light from the disk can reach you. Time is warping, space is bending, photons no longer get in. The light of the disk dims, stretches, redshifts, and finally vanishes altogether. What you're left with is a kind of cosmic silence. Not because the black hole grew quiet, but because you've fallen too deep to hear its last echoes. The brightest, noisiest object in the universe is now behind you. Up ahead, darkness. Not any more light, not any more fire dot. Just the last few seconds of your fall into something that the rules of physics can't fully explain dot. The accretion ring was the last thing the black hole did before it went out. You are now a part of the next one. The inner workings of a black hole. You have crossed the event horizon, and the outside universe has fallen away. The blazing accretion disk, the stars, the galaxies, all of it is behind you now, unreachable. No signal, no light, not even gravity can carry information back from where you are. You are now inside a black hole, entering the most mysterious realm in all of known physics. But what does inside a black hole even mean? To be inside a black hole is not simply to be in a dark place. It is to exist in a region where space and time have swapped roles. Outside the event horizon, you can move freely in space, but are always moving forward in time. Inside, it's as if space forces you to move forward, toward the singularity, with no option to resist. Falling inward becomes as inevitable as tomorrow. It's weird that you don't feel like you're being pulled. Even though you are in a very dangerous situation, you are in freefall and are not feeling any G-forces. Your body doesn't feel heavy. You might even feel calm when you don't have any outside references. The calm isn't real because everything is now moving toward one goal, meeting the singularity. The singularity is not a place, it's a breakdown of space-time itself. It is a point of infinite density and zero volume, where the equations of general relativity shatter under their own weight. Every model fails. Every rule breaks down. Gravity, matter, time, and space all become undefined. This is the heart of the black hole. This is what you are falling toward. But before you reach it, you pass through a zone where our understanding of physics becomes warped, but not yet broken. First, you notice time behaving in strange ways, not just for you, but conceptually. Outside observers would have seen you slow down, freeze, even fade. But for you, time moves forward normally. However, The very nature of causality begins to contort. As you approach the singularity, all possible future paths lead inward. You cannot turn around, you cannot stop. No matter which direction you face, your future lies deeper in. At this stage, strange theories begin to emerge. Some physicists propose that inside the event horizon, time becomes space, and space becomes time. That is, instead of moving through space toward a destination, you are now moving through time toward a point in space, the singularity, as if it were your destiny. And since time only moves forward, so must your fall. But you're not standing on a moving belt that goes faster and faster forever. You're on air. The belt is also not under your feet. It follows you through time, pulling you toward a goal you can never stop or escape. But in a supermassive black hole, the tidal forces at the event horizon are weaker. You may cross it without immediate pain or dismemberment. In fact, you might get remarkably close to the singularity before these forces become fatal. That gives you time, brief but perceptible, to experience the inner geometry of this bizarre place. But what might you see? What might you feel? Inside the black hole, space-time is curved to an almost unimaginable degree. Any light still around you is twisted, curved, even trapped in strange orbits. If a single photon happens to be falling with you, its path may spiral, refract, or blue shift violently as it bounces through collapsing geometry. Your visual field may fill with bizarre distortions, echoes of stars bent into arcs and rings. If gravity lensing is taken to its utmost, some ideas say you might even see the whole universe behind you stretched out into a ring. From your point of view, time outside the event window gets shorter. Before your mind or body breaks, you might have a short chance to see the history of the world speed up and collapse into a single flash. But these are speculative wonders. The inner structure of a black hole is mostly unknown because we cannot observe it directly. We rely on math, on theory, on imagination. And so multiple competing models exist. One such idea is the Cauchy horizon, a boundary deep within rotating Kerr black holes. In these models, passing the event horizon is not the end of the journey. Some solutions to Einstein's equations suggest the possibility of inner horizons, or even tunnels, bridges to other parts of the universe, or other universes entirely. These are often associated with wormholes or Einstein-Rosen bridges. In theory, if a black hole is rotating or charged, space-time may not collapse immediately into a singularity. Instead, there may exist a ring-shaped singularity, which does not destroy everything instantly. Some paths through this rotating core might avoid total destruction, leading to white holes on the other side, cosmic fountains where matter is ejected back into space-time. Of course, all of these possibilities are entirely theoretical. None have been observed. Many may be mathematically elegant, but physically impossible. Quantum effects, turbulence, and instabilities may collapse any potential bridge into oblivion. Still, it's worth considering. Could the inner workings of a black hole be more than just death? Other models consider the Planck scale chaos that dominates the very final moments near the singularity. According to quantum gravity theories, still incomplete, space-time may become foamy, chaotic, fragmented. At these scales, quantum fluctuations are so extreme that reality itself flickers, on and off, wave and particle, everything and nothing. You may not just be falling through space anymore, you could be falling through probability. String theory suggests other bizarre scenarios. It posits that particles are one-dimensional strings vibrating in multiple unseen dimensions. Inside a black hole, these strings may behave in exotic ways, potentially allowing for new states of matter, gravity, and energy. One such concept, the fuzzball theory, proposes that there is no singularity at all. Instead, the black hole is a tangle of strings that spreads out the mass and energy in ways that avoid infinite density. If you follow this plan, your fall might end not in destruction, but in taking in something. Your information could be stored in the quantum state of the black hole itself, making you part of the fuzz. There are even stranger ideas that say the singularity is not the end, but a change. The bounce theory, which comes from loop quantum gravity, says that when things get really bad, gravity starts to push things away instead of pulling them toward it. So there would be a big bounce instead of a fall, or a start over on the other side of the black hole. If you fall into a black hole, could you end up in a different world? Do your atoms compress into a dimensionless point, your existence erased from space-time? Do you become part of the mass of the black hole, your identity destroyed, your story ended? Is this the final page, or just a new book, unwritten and unknown? Inside the black hole, the truth is hidden, not just from you, but from all of science. This is the ultimate mystery. The inner workings of a black hole are a frontier where physics, philosophy, and imagination collide. Space-time curvature and human perception. Picture reality folding in on itself, with light and time warping and the very fabric of existence moving like water. You are now very far inside a black hole. The Newtonian facts of up, down, forward, and backward that used to rule your life have crumbled into something you can't recognize. Things that you see, feel, and think you understand are all being changed. Space-time isn't just a background in this world. It's a live force that is twisting everything you think and feel. To grasp what your senses might endure here, we first need to ask, how does your brain interpret the world when space and time are no longer stable? Your mind evolved to operate in a universe where distances are linear, where light travels in straight lines, and where time ticks forward at a uniform pace. Everything, your balance, vision, hearing, sense of motion, is calibrated to this consistency. But inside a black hole, none of these assumptions hold. As space-time curves violently around you, it no longer follows the neat geometry of a flat plane. Instead, it resembles a warped funnel, stretching you toward the singularity while distorting everything around you. Light, the primary way we interpret our surroundings, is distorted here in extreme ways. Near a black hole, gravitational lensing becomes so powerful that light paths bend dramatically. What you might see is not the world as it is, but multiple warped images of the same object, or even the back of your own head. Light from stars behind you may loop around the black hole and re-enter your eyes from the front. In this way, the black hole becomes a cosmic mirror, bending starlight into halos, arcs, and duplicate constellations. But inside the event horizon, this warping becomes even more intense. Here, space-time itself is flowing inward like a waterfall, and light is caught in its current. Even if a photon is emitted just ahead of you, it cannot escape. The paths of light now converge, bending inward, falling with you. Because of this, your visual field may seem to collapse, the stars forming a shrinking tunnel behind you, spiraling and twisting as they fade into darkness. And then there's time. Inside the black hole, time is no longer a constant rhythm. It is a direction, pulling you toward the singularity with the same inescapability that gravity pulls you towards Earth. But unlike gravity on Earth, this pull affects your very existence. There is no pause, no resistance. You are traveling in time toward a location, a paradox if ever there was one. How does this feel? Imagine feeling every second both stretch and tighten at the same time. Moments can go by very quickly or drag on for a long time. Time is relative, and if your brain is very curved, your internal clock might not work with how well it can handle information. Your thinking may be stuck while the world around you moves quickly, or the other way around. In the last few milliseconds before the singularity takes you up, you could think about things that have happened to you many times before. What does this do to your sense of orientation? In flat space, down is defined by gravity, but inside a black hole, gravity pulls in all directions toward the center. No matter where you face, you are falling inward. Up and down lose meaning. You may feel like you're tumbling endlessly without moving. Your vestibular system, the part of your inner ear that tells your brain how your body is oriented, becomes confused. In zero gravity, astronauts already experience this disorientation, but in a black hole, this is amplified by curvature. Every direction is forward, every path ends the same. Now let's talk about hearing and the absence of it. Space is a vacuum, so you wouldn't hear anything the way you do on Earth. But inside the black hole, you might still hear something. Your own body. Internal sounds like your heartbeat, your breath, and even the rush of blood might be all that remains. But as tidal forces increase and your body begins to stretch, internal vibrations might change, creating unfamiliar, unnatural frequencies, ghostly tones that reflect the distortion of your physical form. Perhaps the most haunting sound is not a noise at all, but the absence of sound. The universe outside is silent now. No more background radiation, no cosmic murmur, only your thoughts. And what of touch? Your skin tells you the temperature, the pressure of your surroundings, the texture of the world. But inside a black hole, where the environment is rapidly falling away into gravitational chaos, these inputs become erratic or cease entirely. You may feel nothing at all, no ground, no breeze, no physical resistance, just the eerie non-sensation of freefall. Or you may feel intense, unrelenting stress as your body is stretched by tidal forces. This could feel like being pulled apart on a molecular level, slowly and inexorably. Even though you are in freefall, the difference in gravitational pull between your head and your feet could become painfully perceptible. As space-time curvature increases, so too does your mental dissonance. Your brain tries to reconcile impossible information. Lights appearing from behind you, time speeding and slowing without warning, objects twisting into impossible shapes. This can lead to cognitive collapse. Some theories suggest the mind might simply shut down, overwhelmed by sensory contradictions. Others propose that you might enter a dreamlike state, a kind of neurological failsafe, like anesthesia before death. Your final thoughts might be fragmented, surreal, a kaleidoscope of memory and sensory impressions compressed into the last flicker of consciousness. There are hypotheses suggesting that the brain, under extreme stress, may generate new patterns of perception. In a space-time with impossible curvature, your consciousness might rewire itself to interpret the impossible. Hallucinations may become coherent. Fractured perceptions might create a new internal logic, alien but consistent. Perhaps in the end, you wouldn't go mad. You would simply change, become something different. And there's one more mystery. Could the curve of space-time change not only how we see things, but also who we are? When the lines between cause and effect are fuzzy, and the present and the past mix, you may start to lose your sense of who you are. Our memories, sense of time, and sense of where we are in the world are what make us who we are. All of those marks might be gone, though, inside a black hole. Your thoughts may loop, repeat, or go in different directions as reality folds and unfolds. If your memories don't happen in a straight line, are you still the same person? If you see 1,000 copies of yourself falling into each other, are you still one consciousness? The physics of relativistic speeds. As you go deeper into the black hole, reality around you doesn't just warp, it speeds up, bends, and seems like it might break apart from all reason. You're no longer just falling at this point. You're getting close to relativistic speeds, which are speeds that are so fast that they start to question how space and time work. But what does that feel like? To an outside observer, your descent slows. They see you hover near the event horizon, time crawling, light stretching redder, movements freezing like a frame in a paused video. But from your own perspective, time flows as normal. You are falling, fast and smooth. There is no sensation of acceleration, no seatbelt straining thrust, no engine roar. Why? Because this is free fall, and in free fall, even at speeds approaching light, you feel nothing. And yet something is changing, not within you perhaps, but in the universe beyond your reach. The laws of relativity, articulated by Einstein over a century ago, dictate that as you move closer to the speed of light, the world around you behaves increasingly strangely. Distances compress, time dilates, mass increases, and perception. It begins to collapse into abstraction. The universe seems to have been pulled forward and squished together into a tube of motion. But this warping doesn't just change how things look, it also changes time. If you watch from far away, time moves more slowly than it does for you at relativistic speeds. This is called time dilation. And it means that in the world above, days, years, or even centuries may go by while you only see a few seconds. There's a chance that you could see the stars age, societies rise and fall, and galaxies move apart in the breath of a person. This makes falling into a black hole more than just a trip through space. It also becomes a trip through deep time. Still, your body doesn't feel anything strange. There is no wind blowing past you or strong shaking in your body. The speed you're reaching is happening in a very quiet way. It may be 99.9999% the speed of light. When you feel relativistic motion, you don't feel like you're moving. You feel like space and time are changing around you. It doesn't look like the world is moving faster. It bends and blurs into a strangely simple form. Ahead of you, the singularity beckons, but even that destination becomes uncertain. In normal physics, space and time are distinct, but here they begin to swap roles. The singularity isn't just a place. It becomes a moment, a time that you are inevitably drawn toward. This is the inverse logic of a black hole. You don't move through space toward a point in time. You move through time toward a point in space. Because of relativistic aberration, light no longer seems to come from all directions equally. Instead, it bunches in front of you like a headlight beam compressed into a blinding tunnel of brightness. This tunnel narrows as you speed up, funneling the visible universe into a glowing circle of increasingly blue light. This isn't a poetic metaphor. It's a real physical distortion of light waves due to your motion. The cosmos behind you redshifts into near invisibility, while the universe ahead blue shifts into ultraviolet radiance and X-rays. Your vision, if it remains functional at this point, would show a universe turned inside out. The stars behind you fade. The stars ahead become lethal pinpricks of radiation. You are no longer looking at a familiar cosmos. You are hurtling through a relativistic hallucination, crafted not by imagination, but by the laws of physics themselves. What about your body? Is it being changed? In the strictest sense, no. You're not speeding up in a way that makes you feel pressured or uncomfortable as you fall. But because of general relativity, your inertial frame is now very different from someone looking at you from outside. From their point of view, you are getting bigger. Time is going by more slowly. There is more life in you. You are changing into a strange cosmic being full of energy who is stuck in a downward slide toward the unknown. In fact, your kinetic energy, your energy of motion, is skyrocketing. You are accumulating more and more energy relative to the rest of the universe. If you could somehow collide with an object from outside the black hole at this stage, the impact would unleash the force of a nuclear explosion or more. This kinetic energy isn't noticeable to you, but it is real, and it defines your transformation from matter to something far more fundamental. At the same time, the curvature of space-time is guiding your path. You're not steering into the singularity. You are being delivered precisely and inevitably along a geodesic, the shortest path through curved space-time. And the deeper you fall, the more that path bends and twists, until eventually all paths lead to the same endpoint. There is no going around, no going back. What you are experiencing is the end of freedom in motion. You are not flying. You are not tumbling. You are being threaded through the eye of the cosmic storm, and the universe is closing behind you. Perhaps at this moment you begin to reflect. Is this how death feels? Not sudden or harsh, but quiet, unavoidable and certain? Or is it birth? Is this what it means to change into a new form of being where time, space and consciousness don't work the way they used to? You are now beyond relativity's simple frames. You are in the deepest part of physics jungle, where general relativity and quantum mechanics eye each other suspiciously but refuse to speak. No theory fully governs what you're experiencing. No experiment has been run. No human has seen what you're seeing. And yet, it all makes sense in the language of falling, light, and time. Experiencing the unknown, emotions and fear. We've talked about science, optics, and how time and space can bend, but perhaps the most human part of the experience is still missing: how you feel, your ideas, your fear, or your peace. Let's strip away the scientific terms for a moment and talk about what it means to face the unknown. Not an unknown like a dark room or an unfamiliar road, but the true, capital U unknown. The kind that obliterates comprehension. The kind that no one has returned from. This is what you face second by second as you plummet toward the singularity. Even before terror sets in, if it ever does, you are likely to feel a kind of profound existential awe. Around you, the universe is no longer a place of distant stars and steady ground. It's a swirling kaleidoscope of warped light, curling space, and impossible stillness. You may be speechless, your senses overwhelmed. There is a kind of cosmic beauty in black holes, an almost divine symmetry in the way they bend reality. For a few moments, you may feel as though you're witnessing the engine room of the universe, as if the laws of physics have opened a backstage door and given you a pass. But fear quickly takes the place of awe. Maybe not the fear of pain, since you haven't felt any up to this point. You're falling without stopping. Not a single force, contact, or pushback is present. You know something is wrong, though. It knows that it can't stay alive here. It knows you're in more than just trouble. You're going to die. People also haven't learned to deal well with things that are inevitable. Something changes in your mind. You start to feel the future falling apart. We usually keep a story of time going forward in our minds, telling us about the next hour, the next day, and the next week. There are dreams, fears, and goals, all wrapped up in a future that looks like it will happen. But as you fall, the thread starts to break. The chance of a future disappears second by second. There won't be any more sun. There will be no more talks. Don't worry about what will happen next. This is all there is. These steps down, in this one way, to nothingness. That's when fear deepens, not into panic, but into existential dread. A quiet, inescapable realization that you are alone and that the universe will continue without you. That your story has a hard stop, not just in body, but in meaning. It's not scary like a movie. It's not yelling and chaos. That's not cold enough. It's the kind of fear that shuts down everything inside you. A space-based stillness. You might try to make sense of it at some point. You are going to think about science. What Stephen Hawking said. More on all the ideas behind singularities, Hawking radiation, wormholes, and white holes. Your mind will look for any story or reason to make what's coming seem less scary. You'll think, maybe there's a way out. Truth may fold in a way I don't understand. This might not be death, but even that comfort is fleeting. Because you'll begin to realize that no narrative survives this fall. No story fits what you're experiencing. This isn't a plotline. This isn't a myth or metaphor. It's real. And it's unraveling you, not physically yet, but mentally, emotionally, spiritually. There's a strange phenomenon reported by people who have faced near-death experiences, extreme trauma, or existential despair. They often report a sense of calm just before the end, a clarity, a sense that nothing else needs to be done, there's nowhere else to be. The fear peaks, and then it breaks. You're not sure how long you've been falling, a second, an hour, a lifetime. That's the other trick the black hole plays. It untethers you from time, not just physically, but psychologically. You can't feel time in the normal way. The moment stops belonging to a clock. It becomes eternal. The descent is a single experience, stretched out, where beginning and end blur. And in that stillness, you may begin to feel a strange sort of connection to the fact that you are made of atoms that were forged in stars, that you are falling back into the source of all gravity, of all beginnings. Perhaps this is not death, you think. Perhaps this is the return. Not like a montage, but more like a sensory flood. Disconnected pieces of who you were, rising up one last time before everything slips away. The brain, under extreme stress and unfamiliar physics, may go through its final surge of self-awareness. And then, nothing? Or something beyond comprehension? That part can't be explained. We don't know the only thing. We just don't know. Our words can't get there. The science we use doesn't work. We can only say that this moment, this last second of falling, is unlike any other the mind has ever seen. And that may be the deepest feeling of all, humility. Understanding that there are lines that can't be crossed with answers, no matter how much we know, think, or plan. Only after some experience, only if you give up. A moment of cosmic isolation. There were stars in the beginning, Earth was there. There were people. There were towns, ideas, and stories. It was all so real, so right now, so there. Of course, as you fall deeper into the black hole, all of that seems far away now. Dim, getting darker. After that, it's gone. This is the moment when cosmic isolation becomes more than a concept. It becomes your lived experience. It is not the kind of loneliness you feel in an empty room or on a quiet night. This is something far more profound, something cosmic in scale, in silence, in permanence. You are alone, not in a room, not in a landscape, but in space-time itself. As you cross deeper past the event horizon, communication with the universe outside is not just unlikely, it is impossible. No signal, no light, no thought can ever travel from where you are now to where you came from. The laws of physics decree it. The fabric of space-time is so curved, so steep, that even photons, the fastest messengers in the universe, cannot climb back out. At this point, it looks like you've disappeared. The next thing that happened will never be known. Not your ideas, not how you feel, not your last breath. To everyone who has ever seen you fall, you are now just a dot on the edge of existence, floating just above the horizon and becoming invisible. They don't see you sink. They can't. From their point of view, time stops at the border for all time. And the most startling thing about this phase is that it might not feel dramatic. There's no crashing, no breaking, no thunderclap. Just the eerie, surreal realization that no one will ever see you again. That your voice, your presence, your entire existence has fallen into a place where it cannot be retrieved. It is not death in the traditional sense. It's a disconnection on a universal scale. Cosmic isolation isn't just about losing contact with other people. It's about the absolute end of reference, of context, of comparison. For the first time, you are in a place where the rest of the universe no longer exists, at least not in any meaningful way. Everything you ever used to orient yourself, light, time, gravity, direction, becomes useless here. Your senses, deprived of familiar input, begin to turn inward. But even that retreat offers no comfort, because your internal compass has been severed from the outside world. There's no up, no down, only in. This might be the closest anyone has ever come to absolute solitude, a kind of pure aloneness that most human minds are never prepared to confront. Not simply being away from people, but being outside of reality as it's known. You are untethered, not metaphorically but literally, from the cosmos. Take a look at that. You're still yourself. You are feeling, thinking, and watching. But what you do, say, or understand no longer changes the rest of reality. No one in the world can see you. It's also quiet, totally and utterly dead. Not like a recording studio or a pressure room, where it's very quiet. This is the sound of nothing happening. There's no wind. There is no sound. There is no radiation. Behind you, not even the sound of the accretion ring can be heard. If you can even call it a sound, the only thing left is the quiet hum of your own organic processes, if they are still working. Your beating heart. Breathe in, the blood in your ears, until even those fade. But something stranger happens next. You may begin to feel the absence of presence. Normally, we experience being alone as an awareness of what is not there. You feel lonely because you remember other people, other sounds, other sensations. But as your fall continues, even those memories begin to feel unreal. Not because you forget them, but because they no longer apply to your context. They become like scenes from a movie you once saw, detached, distant, dreamlike. This moment is all that reality has left us with. It doesn't have anyone else in it. At this point, the feeling is so different from normal life that words can't describe it. What does it mean to be the only person looking at a part of space-time? To feel your mind push up against the edge of what you can understand? To understand that your thoughts may be taking place somewhere no one else will ever see? Some people find the thought scary. For some, it's strangely comfortable. A trip back to the start. Another way to become one with the universe is to disappear into it. Right now, you could think about what it would be like to be the last person in the world. But that's not even close enough of a comparison. Even the last person would still be in the world. But you're not. You are too far away for stars to reach, beyond what other people know as time. In a black hole, there is no horizon to look toward. no sky to dream under, no planet to walk on. There is no frame to hang your thoughts on. And so your mind starts doing what it was never designed to do. It tries to build reality from nothing. It could play back parts of your life, conversations that echo, make up people. You might even start to see things that aren't there, not because you're scared or hungry, but because your brain is desperately trying to connect to something. But in a black hole, nothing stays put. At some point, even time stops having any value. Time is stretched, bent, and spread into vague loops. Your seconds may seem to go on forever. You could also feel like your journey started just a moment ago. Each tick of the clock is separate from the one before it. This isn't just a matter of space. It's about time. You are by yourself in time as well as space. No history, no way out. Only the unwavering right now. In spite of how scary and empty it is, there may be a strange kind of peace. The same peace that people talk about when they are deeply meditating, when someone is close to dying, in drug dreams, the calm of giving up. For this reason, the world can't touch you when you are this far away from it. Don't judge, not remembering. There is no shame or need. That's all from a world you're not in anymore. The final seconds, from distant past to timeless now. By now, you are deep inside the black hole. Light is no longer light. Space is no longer space. Time is, well, something far stranger than you've ever known. Seconds have stretched, looped, twisted. The very meaning of a moment has become distorted. Now you're getting close to what could be your last seconds. However, what is a last second when time has stopped? You were born into a world where clocks and dates run everything. From your heartbeat to your blink, everything you've ever done has been in time's steady beat. But those beats break down here as we fall into a black hole. They don't slow down. They don't go faster. They break apart. You are approaching the singularity, the core of the black hole where gravity reaches infinite density, and space and time are compressed into a point of no dimensions. It's a concept that breaks even our most advanced mathematics. And now it's becoming personal. The singularity is not just ahead of you. In this twisted geometry, it is in your future. Everything, every direction, every force is pointing you toward it. There is no detour, no pause, no reversal. You are caught in the gravity of destiny and the destination is singular. This is how time, your time, starts to fold in on itself. It's possible to feel like the past is after you, like a dream, but like it was real, a real pressure that brings your whole life to a single point. You might start to see time not as a line, but as a loop in these last few seconds. Think about your birth, your first steps, your first love, your fears, and your victories all coming together in the present moment. The singularity doesn't care about time. There is no before or after there. It brings together the past, the present, and the future. And if your mind survives this long, if it can somehow function under the pressures and strangeness of this descent, it may experience something akin to temporal superposition, like a living memory palace, all of your moments laid bare side by side, not replayed but lived again and again simultaneously. It's as if time, the thing you once moved through, has turned inside out and swallowed you whole. What do the final seconds feel like? They feel like everything and nothing. All at once. Your senses may betray you completely now. The distortion of time affects perception too. You may see flashes of childhood, of a planet you once stood on, of people who once said your name. You may hear voices, feel textures, smell ocean salt and autumn air, not as memories, but as living, breathing sensations. And yet you are here, falling, inward, infinitely inward. Your experience of time becomes non-linear. Your brain can no longer assign order to cause and effect. You might recall events that never happened. You might feel emotions before their triggers. Your perception may start layering realities on top of each other, past versions of you overlapping with the current one. There's a theory, speculative of course, that in these last seconds, your consciousness might expand in strange ways. That you may become aware of multiple timelines, or even alternate paths your life could have taken. Not because the singularity grants wisdom, but because the collapse of space-time strips away linearity. Some liken it to the moment before death when people say their life flashed before their eyes. Except here, that flash could become eternal. Not a flash, but a blaze, a burning of identity across every version of yourself. And then silence. Stillness. Not the silence of a quiet room, but the silence of no reference. No ticking, no breathing, no brain waves. Just the edge of time itself. You are now inches, or perhaps picoseconds, from the singularity. And if you're still conscious, you might sense something extraordinary. Timelessness. This isn't just fancy language. General relativity says that inside a black hole, time bends so much that the singularity is always in your future, no matter which way you look. It is what will happen to every cell in your body. And as you get closer to it, time may start to stretch out forever for you. To the rest of the universe, it might seem like you're already gone. But for you, subjectively, the final seconds may stretch so long that they never quite end, like an eternal pause. A breath held at the edge of the void. In this case, you become a ghost of time, stuck not in place but in a second that won't end. If your awareness lasts, this moment may feel like it will never end. It's always right before the singularity, always almost there. You never do, though. This is the strange thing about going into a black hole. You are frozen at the event horizon from the outside. From your point of view, you fall into a last second that lasts forever. The singularity is right ahead. It is infinitely small and dense, but you never quite get there, at least not in a way that our mind can understand. Sensory overload and loss of external reference. Think about being on the edge of reality and knowing deep down that something is wrong, but not being able to explain what or why. Things around you, if you can still call them that, are becoming less clear as you go deeper into the black hole. There are no more stars. There is no up or down, no well-known mathematics. The rules that formed everything you've ever seen, heard, or felt have become completely twisted. Right now, your nerve system is in a critical state, not because of pain, necessarily, but because nothing makes sense anymore. From the earliest moments of life, your brain has learned how to interpret signals. This light means danger. This sound means safety. This temperature means you're alive. But here, inside the warped interior of a black hole, those signals begin to fire in ways nature never prepared you for. You see things, but not in a way that vision can process. The electromagnetic radiation that enters your eyes, if any still does, is warped by gravitational lensing and redshifting beyond ordinary detection. You're bombarded by high-frequency light from the accretion disk behind you, now stretched into bizarre smears of color, like a cosmic oil painting turned inside out. What you're seeing is not the universe. It's a funhouse mirror of reality, distorted images, compressed timelines, light that loops back on itself. In every direction, the universe curves. You look up, you see the back of your own head. You look forward. You see galaxies warped into arcs and spirals, some appearing multiple times, the same image mirrored by gravitational lensing. You look down, and reality seems to pour like liquid into the singularity, streaming away faster than thought. Your inner ear, which governs balance and spatial orientation, goes haywire. In normal gravity, you know which way is down because your vestibular system detects the pull of Earth. But in free fall, inside a black hole, everything is down, and also nothing is. Your brain tries to orient, but there's no up, no floor, no horizon, no sky. The sensory foundation of your world, balance, direction, spatial awareness, crumbles. Disorientation isn't even the right word anymore. You're experiencing cognitive vertigo, a full shutdown of orientation, space, and control. It's what fighter pilots describe in a blackout spin, multiplied by infinity. And then there's sound, or rather, the lack of it. Space, even outside black holes, is mostly silent, but near a black hole, this silence becomes oppressive. It's not the silence of a quiet room, it's the silence of a dead universe. There is no air, no vibration, no waves for your ears to catch. And even if your body produces a sound, like a scream, it never reaches your own ears. You are floating in total sensory stillness. And paradoxically, this absence becomes overwhelming. When the body is deprived of external input, it creates internal noise. Your brain starts inventing stimuli, phantom sounds, imagined touches, memory echoes of light and movement. You begin to hallucinate. In this moment, the boundary between perception and imagination collapses. You may hear voices, perhaps your own, perhaps those of people long gone. Your brain, desperate for reference, begins to reanimate fragments of past stimuli. Music from childhood, the hum of a subway train, the sound of your name spoken in joy or in fear. But these aren't memories. They're projections, mental survival mechanisms triggered by complete sensory absence. Touch begins to lie too. You feel pressure, cold, maybe warmth. But these sensations don't correspond to anything real. The nerve endings that once responded to external stimuli now respond only to internal confusion. You're no longer feeling the universe. You're feeling the collapse of perception itself. You begin to lose track of your own body. Your hands, your legs. Where are they? There's no floor to feel. No wind to caress your face. No gravity to press your weight into existence. In the absence of external forces, your body ceases to feel real. It becomes a suggestion, an echo, a fading dream. And yet, there's awareness. Still, you may be weightless, but that doesn't mean you're at peace. In fact, the lack of physical sensation makes you hyper-aware of your own thoughts, like being trapped inside your own mind, with nothing to drown them out. Your stream of consciousness becomes the only stimulus left. This is where sensory overload meets sensory deprivation. All of the senses, sight, sound, and touch, are either overloaded or not getting enough information, and your brain starts to loop because it can't figure out what's going on. It looks for a pattern, it plays back thoughts, it repeats the same things in a circle. This feels the most like mental clutter that a person can feel. Some theorists speculate that under these conditions, the boundaries between the senses may begin to blur, a phenomenon called synesthesia. You might see the sound of your own thoughts, feel the shape of time, hear the falling of light. You are no longer receiving input from the outside world. You are experiencing a self-contained sensory storm, a chaotic firework of invented impressions. It's the human mind trying to explain the inexplicable. At this point, you may have no idea how long you've been falling. A second, a year, 1,000 lifetimes? Time has decoupled from any external rhythm. You exist in a temporal fog with no sunrise, no heartbeat, no breath to measure passing. And that's when you realize the scariest part. You could be anywhere. You could be nowhere. This is not death. This is not life. This is unrealistic. You may attempt to grasp something, anything familiar, but the concept of grasping has no meaning anymore. There's no gravity, no anchor, no reference frame. Everything your senses once trusted has betrayed you. Your eyes see lies, your ears hear nothing, your skin feels ghosts. And yet, you think, still. Maybe this is the last thing that happens when you fall into a black hole. You are broken up, not of the body, but of the structure of people. The tools that nature gave you to stay alive don't work here. Being able to breathe underwater while your lungs are full of air is like that. Your mind has no background, a being that doesn't have a world, one who has seen how human senses fail in the face of the final void. Still, even now, right here, you are still awake. You can feel that last whisper of yourself, not the person you used to be, but the one you've turned into, a mind lost in a warped universe connected only to the fall. The fall keeps going. Quantum effects near the singularity. You start to leave the realm of traditional physics as you get closer to the singularity, if such a place can even be called that. Einstein's most important work, general relativity, has led your fall so far. It has described how space-time curves, light bends, and how sense orientation breaks down. Now, though, relativity starts to fall apart, and in its place, quantum chaos. The singularity of a black hole is a point of infinite density, where the gravitational pull becomes so intense that space and time are crushed into an infinitesimal point. At least, that's how the math describes it. But nature has a way of resisting infinities. In reality, the known laws of physics stop working here. So what happens next is not something we can define with certainty. But we can speculate, and when we do, we enter the strange, probabilistic, and often unintuitive world of quantum mechanics. Let's rewind for a moment and ask the question, what is the smallest unit of reality? At the quantum level, particles don't behave like neat, solid marbles. They behave like smeared-out probabilities, wave functions of where they might be, how they might move, and whether or not they even exist in a state that makes logical sense. When you approach the singularity, every particle in your body is dragged into this realm where identity becomes unstable and certainty collapses. Your location, uncertain. Your velocity, indeterminate. Even you, as a coherent system, begin to blur. This is the quantum fog, a zone where nothing can be known with precision and every quantity is governed by uncertainty. Heisenberg's uncertainty principle, usually a subtle effect, becomes dominant. The very act of being becomes statistical. You are no longer a person, you are a probability field. How could this feel? Picture your thoughts breaking up, not because you're confused, but because your mind is breaking up into different possible results. You have an idea. At the same time, you have a different thought about it. Then a third, then 1,000. Until you're not having just one thought, but all the thoughts you could have at the same time stacked on top of each other. It's not madness, it's multiplicity. This may sound like science fiction, but quantum decoherence, where particles lose their distinct, classical identity and become entangled in a mesh of probabilities, is a real and measurable phenomenon. Inside a black hole, this doesn't just happen to atoms. It happens to everything, including your consciousness. If consciousness is, in part, an emergent property of quantum states in the brain, a hypothesis still under scientific debate, then those states will now become unstable. Your inner monologue may splinter. You may hear multiple versions of yourself thinking in parallel. It's like being aware of every possible version of your own future, and none of them solid. It's not disassociation, it's quantum disintegration. And yet something stranger may occur. As you collapse toward the singularity, you also experience extreme time dilation. Time from your perspective continues flowing, but from the universe's point of view, your descent is frozen. At this point, your entanglement with the external universe reaches zero. You are no longer connected to the past, present, or future. You are an island of probability floating in space-time. But here's where it gets even weirder. In quantum mechanics, the act of observation plays a critical role in collapsing probabilities into concrete realities. If there's no outside observer to measure your state, then you might exist in a suspended superposition, not dead, not alive, not falling, not still, simply uncollapsed. Now the question is, who or what looks into the middle of a black hole? Do you look at yourself? Is the singularity looking at you? Or is your state going to stay vague forever? Are you really immortal if time is messed up so badly that no outside information can ever reach you? Not in a physical or practical way, but in the sense that your last moment might never come to an end. From your perspective, that final quantum instant, your last second of falling, may stretch into an eternity of undefined potential. This might be the true event horizon, not the boundary around the black hole, but the one inside you, where experience ceases to be linear and becomes instead an infinite pause, a cosmic limbo shaped by uncertainty. Quantum physics doesn't end with doubt, though. It also shows that particles are very closely linked to each other. No matter how far apart two particles are, their states stay connected when they become intertwined. If your atoms are linked to the universe's atoms, which they almost certainly are, then bits of you may still be heard outside the black hole. Your fall may be invisible, but your information, it might still matter. And herein lies one of the greatest paradoxes in theoretical physics, the black hole information paradox. Stephen Hawking once proposed that all information falling into a black hole is lost forever. But this breaks the fundamental rule of quantum mechanics. That information cannot be destroyed. Later theories suggest that the information is preserved, perhaps encoded on the event horizon, or slowly radiated out through Hawking radiation. If true, it means that your fall is not meaningless. It means that somewhere, somehow, your existence is being etched into the fabric of the universe, distorted, scrambled, unrecognizable, but not gone. You keep going even after death. Photons that are spread out, time and space are twisted, quantum memory is used. Going into a black hole might not be the end. That might be the weirdest truth of all. Some people think it's the start of a new state of being where the strange reasoning of quantum fields rules instead of biology or physics as we know them. And while you're on the edge of singularity, torn between ending and continuing, you might not feel pain, fear, or identity. The role of Hawking radiation. There's something going on beyond the event horizon as you fall toward the center of the black hole. You might never feel it directly, but it has a deep connection to the fate of the whole universe. It's not clear, it takes a while, but it's important. It's Hawking radiation, a soft glow that whispers from the edge of the black hole, like a fire that is dying. In a strange turn of events, it may also be the last record of your life. Let's rewind. In the mid-1970s, physicist Stephen Hawking made a radical prediction. Black holes aren't entirely black. Though they trap everything within their event horizons, they also emit radiation, a thermal glow caused not by the black hole itself, but by quantum processes occurring just outside its boundary. This revelation flipped everything on its head. According to classical physics, nothing escapes a black hole. Not light, not matter, not information. It was the ultimate one-way door. But Hawking's work, combining quantum field theory with general relativity, suggested otherwise. And it started with empty space. You see, in quantum theory, even what we call vacuum isn't truly empty. It seethes with virtual particles, pairs of matter and antimatter particles that blink into existence for the briefest of moments before annihilating each other. Under normal conditions, these particle pairs appear and disappear too quickly to have any lasting impact. But near the event horizon, everything changes. Here, the gravitational field is so intense that it can separate these virtual particle pairs before they annihilate. One particle falls into the black hole, the other escapes into space. The escape particle becomes real, contributing to what we call Hawking radiation. But where does the energy for that escaping particle come from? It comes from the black hole itself. Every time a particle escapes, the black hole loses a sliver of its mass. Over billions and trillions of years, this slow leak would cause a black hole to evaporate entirely, shrinking, dimming, and finally vanishing in a last burst of radiation. Here's the catch. As you fall into the black hole, you could be part of the data that's being sent through this radiation. What? How? Let's get closer. When a particle goes into a black hole, it has negative energy compared to the rest of the universe. This thing makes the black hole less massive when it is added to it. That being said, the particles that fell in and the particles that got out were once quantum entangled. Information is sent over that link. Even though you, the falling observer, pass the event horizon and vanish from external view, your mass, your energy, and perhaps your information influence the virtual particles flickering into and out of existence near the horizon. It's possible, just possible, that the outgoing radiation remembers you. This would solve a massive problem in physics. See, quantum theory insists that information cannot be destroyed. Every process, every particle interaction must be reversible. But if black holes destroy everything they consume, including the structure, identity, and information of matter, then quantum mechanics breaks. Hawking himself struggled with this. For decades, physicists debated whether information truly disappears into black holes. If it does, it challenges the foundation of quantum physics. If it doesn't, where does it go? In recent years, a growing number of theorists believe the answer lies in the radiation itself. That Hawking radiation isn't just random heat, that it might be subtly encoded with the information of everything the black hole has swallowed, from ancient stars to rogue atoms to unlucky space probes, to you. If that's true, then the black hole doesn't destroy you. It scrambles you. It transforms you into radiation. You, a conscious being, built from stardust and memories, falling into an abyss, stretched by tidal forces, unraveled by time dilation and quantum chaos, could still leave a fingerprint behind. Your essence might radiate back into the universe, not as a person, but as patterns, encoded in the flickering heat that leaks from the boundary of eternity. To an external observer watching from far away, this glow would be unimaginably faint, one photon at a time, scattered across eons. But in theory, if someone could capture every photon and decode their quantum states, they could reconstruct the history of the black hole. This is no longer science fiction. It's a real cutting-edge area of physics involving topics like the holographic principle, quantum entanglement, and string theory. One idea suggests that the event horizon is like a cosmic hologram, recording every piece of information that falls inside. This boundary, like the surface of a CD or DVD, encodes a three-dimensional experience in 2 dimensions. And what we think of as the inside of the black hole may be a projection from this encoded surface. That means your fall was never really inside the black hole. It was only information on the edge the whole time. That thought might be true. If it is, then maybe death in a black hole is not destruction, but decryption, the changing of your being into a cosmic broadcast. From your perspective, nothing changes. Hawking radiation happens on timescales far longer than a human lifespan, trillions of years. You're not aware of it. You don't feel it streaming away. It doesn't slow your fall. It doesn't offer escape. Falling through the point of no return. There's a moment in this cosmic plunge when you cross a threshold that separates the universe from something else. It's invisible, silent, deceptively calm. But make no mistake, you just passed the point of no return. From the outside, it looks like nothing at all, just an invisible shell surrounding a black hole. No shockwave, no flash, no gate. It's as though the cosmos forgets to draw a line where everything changes. And yet, this moment is more profound than anything you've ever experienced. Let's rewind a second, literally. Just 1 second before you passed the event horizon, light from distant galaxies still reached your eyes. Time was warped, sure. Space was twisted. But it all still existed. You could still, at least in theory, turn around and escape, though you'd need engines stronger than anything humanity has ever built. That last photon from the outside world hits your eye. The final flicker of a star billions of light years away, and then blackness. Eternal, unyielding, everything you've ever known, the entire visible universe, has been cut off. This is the paradox. Crossing the event horizon feels like nothing, but it changes everything. You've entered a region of space where the fabric of reality folds inward. The escape velocity is now greater than the speed of light. Nothing, no signal, no particle, no plea, can leave. Even if you shouted at the top of your lungs, the sound would never escape your throat, because sound requires air, and there's nothing here. But more than that, even light can't get out. You could fire the most powerful laser ever made straight upward, and it would curve back down into the black hole like a boomerang. This is the edge of physics as we know it. To you, everything still seems eerily normal. You're floating, drifting. The stars are gone, sure, but there's no crushing weight, no heat, no pain. Yet this sensation is deceiving. The laws that govern your experience, the scaffolding of space and time, have been rewritten. And you are now on the inside of infinity. So what's it like? First, the horizon itself. From your point of view, the event horizon doesn't look like a wall you crashed through. In fact, it's not even around you anymore. As soon as you cross it, the horizon slips behind you. But this is where geometry turns weird. Inside the event horizon, space and time swap roles. Out in the normal universe, you move through space, and time moves forward, whether you like it or not. You can walk in any direction, but you can't walk backward through time. Time is a one-way street. Radial space becomes time. That means forward in time is now the same as inward toward the singularity. You have no choice but to move toward it. Not because you're falling, but because moving forward in time is falling. It wouldn't matter if you had a rocket that was infinitely strong. You can't stand still. You can't turn around. You're not hovering in place. Going deeper is the only way. Imagine that the computer in your suit is still keeping track of speed and distance. At first, it might say that you are a few thousand kilometers from the middle, then a few hundred, then 10. Next came fractions. You are still falling, but not as much as before. You are now in a space-time tunnel that is pulling you closer and closer to a certain end. The twisted shape gets stranger with each second. Things start to go wrong with time. From the outside, it seems like time has stopped for you. From afar, it looks like you're stuck at the edge, never quite falling in. But from your point of view, time seems to be moving properly. Every moment is real for you, and nothing seems odd until you notice that the clock is actually off. The way clocks work inside the black hole is different. They can still spin their hands, but they are spinning away from everything. Your brain tries to keep up by organizing time as a series of events, but these scenes might fall apart here, in this twisted field. You might see flashes of memory, moments folding in on themselves. A strange déjà vu that seems to echo from events you haven't lived yet. Could it be your brain glitching under stress? Or could it be that inside this timeless place, the concept of before and after begins to break down? This is where physicists get nervous, because nothing inside the event horizon can be directly observed. No one knows exactly what happens here. Our best theories dissolve into contradictions. General relativity tells us gravity gets infinitely strong at the singularity. Quantum mechanics tells us that infinities are nonsense. We don't know how to resolve it. You are now part of that mystery. Your molecules are still intact, at least for now. You're not yet a spaghetti strand of atoms, though that moment is coming. The gradient of gravity hasn't fully crushed you, but space is no longer space, and time is no longer time. What will happen next? You trip and fall inside, of course, just for a little while longer, perhaps a minute. As you move into a part of space, continuity starts to fall apart, where the past and the future meet and become one place, where every path stops, not in a place, but in an idea. Gravitational waves and their effects. As you descend into a black hole, something changes. The silence is disturbed, not by sound, but by a shiver in the very fabric of space. This is not wind, it is not heat, it is not light. It is a gravitational wave, a ripple in space-time itself. What are gravitational waves, really? Albert Einstein predicted gravitational waves over a century ago, but we only confirmed their existence in 2015, when LIGO detected the collision of two massive black holes over 1 billion light-years away. What it sensed wasn't noise in the air, but expansions and contractions of space-time itself, stretching and squeezing Earth ever so slightly. These waves aren't disturbances in space, they are disturbances of space. Like ripples on a pond's surface, gravitational waves travel outward from massive accelerating events, colliding black holes, neutron star mergers, perhaps even the violent birth of the universe. And now, as you fall into the black hole, you feel them. Suppose that you are in the middle of a fall in a spaceship with all of its sensors and tools ready to go. The walls seem to pulse all of a sudden. At first you might not notice it, but your surroundings start to stretch in one direction and squeeze in another. You're not moving. Space is. You reach out to touch a wall, and it's slightly further than you expect. A moment later, it's closer again. If you had two free-floating spheres on opposite sides of the ship, you'd see the distance between them oscillate, despite there being no wind, no engines, no visible force. That's the gravitational wave passing through. It doesn't push you. It doesn't shake your ship. It changes the distances between things. As you dive deeper into the black hole, the frequency and strength of gravitational waves may increase dramatically, especially if you're entering a region where stellar remnants are colliding, or if you're near a binary system feeding the singularity. Every wave bends space-time in steady bursts, like the heartbeat of the universe. Some go by quietly, some bounce very strongly. Even though you can't hear them, you start to feel their presence, like a jolt in your bones, or a change in the way you see things, as the space around you changes just a little with each wave. It looks like the stars are moving. It looks like the darkness is breathing. Gravitational waves are incredibly weak by the time they reach Earth. They need events like black hole mergers to even be detectable. But here, in this environment, they're no longer faint whispers. They are cosmic drum beats. If the wave is strong enough, your very shape could be altered, temporarily stretched, or compressed. You wouldn't feel it as pain. There would be no crushing, no ripping. Instead, it's like your body, your thoughts, your measurements of space itself are being modulated, as if existence were a fluid medium, and you are a ship tossed on an unseen tide. Some speculative theories suggest that regions near supermassive black holes might be roiled by gravitational wave turbulence, constant, overlapping ripples from merging stars, accreting gas, and fragmented debris falling in. This could manifest as a storm unlike anything in our solar system. Instead of wind and rain, it's made of geometry, space and time warped on repeat, tangled in wave after wave. Some areas might stretch chaotically, others might compress or twist. In this churning ocean of curvature, your trajectory would no longer be straight. You would ride not a fall, but a wave front of cosmic distortion, potentially altering your path, spinning your body, even influencing what you see. This isn't made-up science fiction. It's a guess based on what general relativity lets us know. Gravitational waves might make things flash if you could see them, maybe by the way light bends around you. As the wave goes by, the starlight behind you might change shape for a moment, stretching into rings or arcs. Or light sources that are closer could dance, making it look like they move with each pulse. It's not that your eyes are getting worse. Space is twisting in real time, which could make it hard for you to see straight. Waves bigger than planets and moving faster than bullets are changing every frame of your internal movie. Even your sense of time might be affected. A strong enough wave can momentarily accelerate or decelerate the ticking of a clock, including the clock in your mind. Seconds stretch, compress, dilate, and you begin to lose track of what is cause and what is effect. Eventually, the waves may crescendo. If you're near a merger or caught in an intense gravitational well filled with turbulence, the overlapping waves might create resonances, zones where space-time warps more intensely, unpredictably. Here, space-time distortions and tidal forces work together to make an experience that is unlike anything else in nature. The black hole's gravity pulls you in, but the waves move you around. One minute your body may feel weightless, the next it may feel stretched out, and the next it may feel bent. You are no longer falling straight down. It's chaos where you are. Take a moment to understand what you are seeing before you fall too far or the light goes out completely. Are those waves you're riding? They are echoes of things that happened billions of years ago, the last cry of a dying star, a crash that bent the universe, the last breath of a star. You are falling through space and time, but also through the memory of the universe, which is etched into space-time like ice on a lake. Gravitational waves are old and move at the speed of light. As you fall deeper, you are their witness. As time goes on, the song changes as we get closer to the singularity. The number goes up, the waves get smaller, the waves get bigger. As you get closer to the center, the pulses may change from being smooth and peaceful to dissonance, which is a high-frequency chaos that blends with the way space-time is curved. The wave and the fall become one in these last seconds. Temperature extremes and radiation exposure. A new sensation begins to emerge, one that is not visual, not tactile, not even emotional in the usual sense. It's hot, not the heat of a summer's day or the warmth of a fire, but something far more primal and unforgiving. This is the heat of the universe at its most extreme, and unlike anything you've ever experienced, it is not confined to one place. It is everywhere, and it comes not just from the environment, but from reality itself being torn, compressed, and supercharged. You are now feeling the temperature extremes and radiation exposure that define the next seconds of descent into a black hole. At these temperatures, atoms break down, electrons fly free, and what was once gas becomes a plasma inferno, glowing across the electromagnetic spectrum, from X-rays to gamma rays. If you're falling into a black hole surrounded by an active accretion disk, you're not just descending into gravity, you are diving into radiation. These aren't the soft glows of visible light. X-rays and gamma rays are high-energy photons, so energetic that they can pass through materials, damage DNA, and break molecular bonds. In everyday life, we're protected by Earth's magnetic field and atmosphere. In space, particularly this close to a black hole, you have no shield. The accretion disk emits a storm of invisible light, each photon carrying deadly energy. At this level of exposure, your body would begin to feel effects almost instantly, though not in a way you can easily detect. There's no sunburn here, there's cellular collapse. You're being bombarded with radiation that your nerves cannot sense, but your cells can. It destroys tissues from the inside out, shattering the integrity of proteins, genetic material, and cell walls. Over time, the radiation would cause extreme damage, if time still mattered. But in your frame of reference, you may not live long enough to feel the cancer or even the decay. In a black hole environment, temperature becomes more than just a sensation. It becomes a fundamental force acting on your body. You might imagine heat as a burn, but here, it's not skin deep. There are no flames, no source. Instead, everything around you, and even you yourself, is gaining thermal energy. Imagine the atoms in your body begin vibrating faster and faster, your core temperature rising without cause. There's no fire, just an unrelenting influx of energy. Your flesh doesn't burn, it evaporates. Your water content turns to plasma. Your skin peels away at a molecular level. Muscles and bone flash heat into dissociation. In theory, you might never feel pain, because your nerve cells die before they can send a signal. But the weirdest thing is that you might not even notice this. Why? You feel like time is moving more slowly. As you keep falling deeper into the well of space-time, the seconds seem to stretch out in front of your eyes. As seen from the outside, you're already getting close to the event horizon at what looks like a standstill. You may think that time is still moving properly, or even that it is moving more slowly. This separation means that your body could be falling apart completely, while your brain, if it's secured by a sci-fi shield or theoretical suit, can only see the start of it. You can see that the light is changing. Your surroundings are twisting, and pressure is building from inside, not outside. Heat that comes from nowhere, pain that doesn't make sense. After that, the walls start to get closer. For the sake of the story, let's say you're not naked in space. You're inside a high-tech spaceship that was made to survive in space. It might have some kind of made-up nuclear protection. Then, heat control is still your biggest threat. Your ship has to send any heat it takes back into space. But when you're close to a black hole, the environment fills your skin with photons of very high energy. So, you take in more energy than you can lose. If we keep going with the thought experiment, once you pass the event horizon, you're no longer connected to the world. You can't get any more radiation from the outside. Is it cooler inside then? Perhaps. Some ideas even say that you might fall into a quieter, colder area inside the event horizon, away from the chaos of the accretion disk. Not because it's cold, but because there's nothing to keep you warm. You were hurt on the way in, though. Your body might have been broken, turned into steam, or turned into spaghetti. There is no down to aim for inside, just a curve. No matter how cold it gets, the damage is already done. This story has one more twist, the black hole firewall paradox. Some scientists think that the event horizon might not be a smooth line, but rather a wall of high-energy particles or a quantum fence. If it's true, falling in would be like slamming into a quantum explosion, a huge release of energy that burns you up at the horizon. Some people still don't believe this, but if it's true, you'd never get past the edge. You would be reduced to particles and radiation, and your data would be mixed up and lost in the chaos of the sky. No easy way through, no strange fall, nothing but destruction. Still, the question stands: can someone really feel this much destruction? The answer lies in the difference between what your mind can still perceive and what happens to your body. You've now crossed the event horizon, not just of a black hole, but of human understanding. What lies beyond is still unknown, yet deeply poetic. Black holes aren't just cosmic death traps. They're windows into the nature of time, consciousness, and perhaps what comes after. If this journey sparked awe, curiosity, or a little existential wonder, subscribe for more deep explorations into science, mystery, and the edge of imagination. Leave a comment below. What do you think lies beyond the singularity? Until next time, stay brilliant.